Hi everyone, back again. This video, we've got something a little bit different. Earlier in the year, with a colleague of mine, Christina Anderson, was very happy to be invited to do a workshop on generative drawing. So art and code and drawing and pens at the International Conference on Computational Creativity. It should have been happening at Coimbra in Portugal this week. Unfortunately, we're in the middle of COVID at this point, and hopefully you're watching in the future and things have improved and people are safer. But we were able to modify the workshop, which was about coming together, talking about what generative drawing is, how you work with computer systems as an artist or a designer, an engineer or a creator, and where the balance of creativity, computation process, and the interest in that process lies. We weren't able to do it in person, which we'd planned as a couple of days, and we expanded the scope of what we were doing, but compacted it into a series of short workshop sessions online using video conferencing and working with remote materials. All of the source code that we went through is online, and we were fortunate to be joined by participants from California, through Europe, all the way through to Japan and into Australia, working across massive different time zones. So what I'm going to show you today is the first session video. It's about 2 hours long, where we go through a whole load of discussion, and there's some really interesting points being raised by participants about their interests and where this issue with working with pens and paper, which we do a lot of. And there's a couple of exercises that you can join in if you're watching this at home or in the studio. Please do actually join in with what's going on, where we talk about designing systems for drawing. And then we start to move into coding with some code examples built in openFrameworks. If you look at the link below, you can see all the running order from the workshops and the links to the source code. There's a whole range of examples that in this video I don't go through, but they're available in the repository, and I'll be doing future videos looking at different techniques and different approaches that you can work through at home. Please do have a look through, and if you're making your own drawings, post links to them, post questions, and I will look forward to seeing you on a future video. And I just want to say thank you very much to all of the organizers at ICCC this year and all the participants for making it happen in really difficult circumstances. So enjoy the video, leave me some comments, subscribe, and I'll see you next time. Good morning, good afternoon, good evening to everyone out there. My name is Dan Buzzo, and I'm here with Christina Anderson from Technical University Eindhoven. And I guess this is the beginning of Introduction to Generative Drawing, which is a workshop that we're running today here at the ICCC conference. So I want to say thank you very much to everyone that's joined us. I think we have a couple of people from around the world here. Yingtao Chan, I believe. You were about to tell us where you were, and then you had to go and answer the doorbell for a package delivery. Sheldon, I think you're in Australia. Welcome to Max. Welcome to Pedro.
No, actually, it's Japan.
Okay, welcome. Really nice to meet you. And see you, Lionel Wong, Amilcar, George Wright, and Dan van den Berg. I just want to say thank you very much to everyone for joining and introduce you to my co-host, Christina Anderson.
Hello, hi, my name is Christina Anderson. I am going to be co-hosting today. What we're going to talk about is really talking about generative drawing, and I'm coming at it from a slightly different side, since I am working these days primarily in textiles and in additive fabrication, which of course is another way of taking a line for a walk. So in that sense, this is very much the point of view we'll be coming from today. And I'll let Dan take over the introductions and mute myself again.
Providing everyone is okay, I'm going to record the session today. If you have any concerns, please do let Christina or myself know, and we can either cut out portions of the content or not release it online. But a couple of people in various different time zones coming from California through to Australia have said, will there be a video online? Or I'm committed to another workshop, but I'd really like to see what's come out of this. So I'd like to put this video online afterwards, along with some additional walkthroughs that I've been doing, which will go onto a YouTube channel about art and code. If you have any concerns, or there's anything you would like redacted, or you're not comfortable about having your voice or your contribution added to that, please do let myself or Christina know, and we will, of course, honor your requests there. At the end of the week, it would be really nice if we can share all the things that we've done. But the structure that we've talked about, as we have to accommodate the lack of travel, lack of being co-located, but at least we're together temporarily, is to put together a structure that looks a little bit like this. So hopefully you can see all the screen sharing. Could you give me a thumbs up or a yes if you can see the screen sharing?
Yes.
Max, thank you.
Yes, I see the screen
Cool,
sharing.
great. So
Yes.
the workshop will only be happening through today officially, and these are Lisbon times. So I think it's GMT +1. So now between 11 and 1 p.m. today, for the next 2 hours, we're going to do a group session. And I'd really like to introduce a couple of ideas and really open it up to your questions, your contributions, your input, your experience, because there's some things that I think are important to consider, but I don't necessarily know what the answers are. Some of which I don't know that there are answers, but they're certainly very important points of view. So for 2 hours, we're going to do a group video session here, do some drawing, some exercises, look at coding. And then this afternoon, between 2 and 4 p.m. Lisbon time, I'm going to be on the Slack channel with Christina, and we're going to be doing feedback, and particularly myself, I'm going to be doing some code support, code sharing, helping out as much as possible. And through the Slack channel, which hopefully you've all joined to at ICCC, we can also video share and screen share. And then between 4 p.m. and 6 p.m. At the end of the day today, hopefully we can all come back together and share video and talk about the experience of doing this workshop, what we found. Hopefully you will share some of the things that you've made and built, and we can collate them. And that will be officially the end of the workshop running today. Of course, all of the documentation is online on GitHub, the source code and examples. And then through the week, between Tuesday and Thursday, I'm going to keep on the Slack channel, allowing for different time zones, etc., to have discussion with you and hopefully do some code sharing. And then on Thursday, we will see whether this works out the way that we hope. It would be great if people can share code and share screenshots or videos of what they've built. And I'm going to put together a small web gallery. And talking with the organizers of the main conference, they're very keen to sort of promote that and sort of announce it to the public a little bit on Friday. So we see how much material we generate and discussion from that. And if it's very small, then we'll do a small thing. And if it's bigger, let's make a bit of a shout about it and maybe keep this discussion going. At this point, does anybody have any questions or any issues or any things that they want to ask? No? Okay, let's move on. So between the sessions, we're going to follow the Slack channel. We're going to use Zoom for conferencing this morning and this afternoon. The links are all on Slack. The Slack messaging channel, which hopefully you've all come to or come from to the Zoom and also via the Google Doc, is at ICCC'20 slack.com. And you can join there, and there's a sub channel for us and you can chat. And I'm live in it now and will be throughout the week. So hopefully you've been able to read the documentation about the workshop in advance, and our original hope was that we would be together for a full day session and very much have a sharing workshop support session. But hopefully you've got pens and some paper, and you'll have a Mac, PC, Linux, something like that, with a text editor of your favorite persuasion and a C++ compiler that works. And hopefully you have downloaded in advance and installed the openFrameworks openFrameworks toolkit for C++, which you can get from openFrameworks.cc. Now, if you haven't done these things, don't worry. You can still get quite a lot out of the workshop and see the examples, and we'll walk through some of them. If this is all gravy for you, then I'm really happy to get involved in more engaged conversation, especially to learn from what you're doing in your practice. So could I just do a quick sort of show of hands or comments? And we now have 15 people in here, so I'm welcome to all of the people that are joining us in the workshop. Can I just run around and see who has done work in openFrameworks or has been coding generative drawing work or other kinds of generative code work before? Anybody want to volunteer anything? Okay, I'm just going to go around and name people. Yingtao Chan, you joined us briefly earlier and then ran off to collect packages from your door. Do you want to tell us what you've been doing in one sentence?
Oh, I have been doing some generating models for example, for art and also for some more computer science like network.
Nice. Have you used openFrameworks before?
No, to be honest, no.
Okay. If you've been programming, you'll be able to come to it very easily. The documentation is very good and the community is supporting it very good. Shelvin, if you're still with us, do you want to give us one sentence about what you've been doing and what your experience or interest is?
I'm totally new to this framework, but I've used generative design for robotic applications in the past. So that's where I'm coming from.
Okay, so quite heavy duty stuff by the sound of it.
Yeah, kind of.
Cool. Mags? So I'm just calling out everyone as they appear on the screen. I'm running multiple monitors.
No worries. Sorry, I was just working on something else. I have no experience whatsoever, and I actually come from a non-graphic design background. I am more of a poet and musician.
Excellent. Well, I think you hopefully will be in good company. Pedro.
Sorry. Yes, I have experience with processing. I've done some generative coding with processing, but I have no experience with openFrameworks.
Yeah.
openFrameworks, sorry.
If you're comfortable with processing, then you'll get on fine with C++. It's just a little pickier in places, but what's nice is it can run much, much faster than processing. It's easy to run on multiple platforms, but there's a big argument about which is, I think processing is easier to get into because the development overhead is lower, but C++ is faster. So they're much of a muchness, but hopefully you'll get something from this workshop.
I'm familiar with C++, not with openFrameworks.
Yeah. Okay, good. Well, hopefully this will be interesting or useful for you, and you'll also have your things to contribute later on in the day. Lionel. Can I just say hello to you and ask you what your sort of experience is?
Hi, Dan. It's great to be here. I'm actually starting my doctoral studies in school, and I am interested in computational creativity. So a bit of my experience, I tried P5.js to generate art, and I've also worked in 3D on Rhino and Grasshopper also to generate forms through code, but I have no experience with openFrameworks so far.
Okay. Well, hopefully you'll get an overview of that, although this is not specifically about beginning to learn openFrameworks, but hopefully it opens up for yourself and other people that may be interested in openFrameworks, a quick structure, and we can work through some examples, and I'm very happy to share what my experience is throughout the week, and I'll hopefully also learn from you all. So Amilcar, I know, is one of the organizers. I don't know whether you're in the chat or just hovering, bouncing through the workshops.
Hi, hello, everyone.
Hi.
Hi. I'm actually just checking if everything is okay. But in any case, this is quite interesting, and I will try to follow as much as possible. But it will be very difficult to intervene actively in the workshop, as you understand. Yeah. By the way, I'm familiar with C++ and with processing and Java and so on and so on. but never worked with openFrameworks. Good luck with workshop.
Thank you very much. And I must say, thank you very much.
Very exciting.
Yeah, I really, apparently my internet connection is unstable. I want to say thank you very much to yourself and all of your colleagues who've made this happen. I was involved with the ACM DIS conference earlier in the year, so I really do appreciate some of the challenges of trying to organize conferences in this way, especially remotely and run workshops. So thank you very much for everyone being amazing.
You're welcome.
Hi, so Sophia, I'm also kind of hovering around, seeing if everything is working okay. I'll try to follow as much as possible, but sometimes I have to leave. So have a wonderful experience. Thank you for, coming to our community.
Sophia, thank you very much. And also thank you very much for accepting the proposal for the workshop all those many months ago.
It's a pleasure.
Going on, George, how are you doing? Are you with us still?
Hello, yeah.
Hi, what's your experience or your interest today?
So I'm mostly, my background is mostly in language processing, but I thought I'd come and see what this is.
Oh, good. Well, I hope you find something interesting. Dan, are you with us?
Yes, I am. 1 second.
Hi.
Hey, my camera isn't working. Sorry. Hi, Dan.
Hi. Welcome.
Hey, man. Yeah, I'm a little bit out of place in this whole conference and in this workshop because, as you might know, we know each other from UvA. Remember?
Yes, of course.
And we used to be colleagues there, and I think I'm a little bit out of place because I'm usually in algorithmics. So my experience on this list is, and I'm really joining because I knew that you were organizing this workshop. I'm just putting you on as a kind of a podcast. But my experience in this list is mostly programming. C++, and I'm in algorithms, so I do something quite different, but I'm really looking forward to listening to what you're organizing.
Hopefully, as with many other people, there's something that you find interesting or exciting, and particularly really keen to hear different people's perspectives and advice and support, rather than this being some expert session that you just listen to. So if you do have comments or observations, please do add them in. It's very much about being a workshop together, rather than some expert system talk, because you'd probably need an expert to do that. So going on, Chip, exclamation, has just joined us.
Hi, can you hear me?
Yeah.
Oh, great, yeah. Well, I'm doing my PhD research in co-creative drawing systems. So I'm really interested in drawing and different approaches of how a machine might draw with a person. So it's in the context of robotics. I've done a lot of processing with creating graphics using processing. openFrameworks is new to me, but I'm really interested in like all the different kinds of approaches that have been kind of developed over the years with how how might one organize like different drawing approaches. So the list of links have been very useful on the tutorial page.
Yeah, thank you very much. The reading list there is just some of the things that I found that have inspired me, I've agreed with, and some of which I disagree with. But it's really interesting to see this spread of approaches of thinking about creativity, computation, drawing, and particularly coming out of artistic practice, where individual artists or designers feel their practice is, and how that works with complex systems. So really interested to see what your thinking is and the sort of opinions and ideas that you've been reading and being exposed to. Hi, Min. Hi, are you there with us?
Hi. Hello. I'm product designer, and I have no experience in processing, but I have experience in Lino and Grasshopper.
All right. Okay.
I don't know if I can follow this tutorial, but I will do my best.
The tutorial, for me, the inspiration point is actually working with a pencil, working with a pen, and the coding, whether you want to work in openFrameworks, which I've been working with the last couple of years and really like a lot, or processing, or Rhino, or even just staying with a pencil and paper, is an implementation detail. Working when you're with a machine, you can do things much, much faster. But for me, it's about working with a pencil and thinking about the problem. So hopefully you'll be in good company.
Thank you.
Suyash Joshi, are you there with us?
Yeah. Hi. Very excited to be here. I am new to both generative art and openFramework. I've done some creative coding type projects in processing, Max, and but very excited to learn more in the workshop today.
Great. Well, thank you very much for joining us. And I think last we have Ana Rodriguez. Are you there with us or here with us?
Hi, I'm here, but I'm just organization. I'm here to help if you need something.
Oh, okay. Anna, thank you very much. You're very welcome. If there's any suggestions that you can add, if there's any technical issues, because I think both Christina and I are running multiple screens and trying to do all of the stuff, please do post it in the chat or contribute, and hopefully you find something interesting. And we have one more just joined us to make 16 in the workshop. Zé Maria and Bruna, you just joined us. Welcome. We're just asking everyone a little bit what their interest or background is, whether they're doing work or they're a programmer or an artist or a designer. Could you say in a sentence hello and what your interest is today? Possibly Bruna will make a comment in a minute. So we're all here today, and the idea is looking at this issue of working with machines, either from a computational or an engineering computer science side, or from a creativity interest, or from an artistic interest. And I want to start with a very simple thing. And I'd like everyone to, if you have, pick up a piece of paper and a pencil and draw. So hopefully I can switch to the drawing camera that I have set up here. Or maybe not. Okay, I'm going to work out how to switch the drawing camera in a minute. Zoom is not a platform that I use, and also actually incidentally my university legally doesn't allow us to use for anything but the most basic. But what I'd like you to do is take a piece of paper and a pencil, think of an integer x between 1 and 10, and then just together we're going to do this as a drawing exercise altogether, and hopefully hold stuff up to the camera and show. Draw 100 lines on the paper, X centimeters long. So if you have a ruler, do it with a ruler, and if not, draw any kind of line that you want at this X length, with two conditions. The lines must not touch each other, and the lines must not touch the edge of the paper. So, hey, I can see people drawing already. This is great. So people on drawing cameras, and I'm going to see if I can add in my video.
Dan, if you share your screen, you will be able to see all the videos.
Okay, great.
Or actually, this view, you'll get it as well.
Mm.
So for everybody, if I'm assuming everybody's very familiar with Zoom, but if you go to the top right corner, you have a mosaic view. If people are drawing on camera, you'll be able to see them do so there. And I'm going to get busy doing some drawing as well. But while we sort of getting started, I just wanted to specifically shout out to Max and Hyman and Chip and talk about, just quickly say that the way I'm coming into this is that I also do not code. I can, but I don't use it in my practice. And my interest in this is really to think about how do we collaborate with systems as human beings, as these kind of weird, wet biological things, and specifically trying to think about what are these lines, what might these lines mean outside of the material of pen and paper. So that's just to give you an idea of the broadness of what the kind of conversations we're hoping to have today. I'm going to mute myself and do some drawing now.
How are people getting on? I see people drawing away busily, which is so nice. I've done this process a couple of times with different groups and also with colleagues and other artist friends and designers. And there's always a beautiful moment of quiet concentration that, of course, I'm now talking all the way through, but it's really nice to see people drawing away and thinking about what they're doing. if when you get to the point of finished with your 100 lines, if it's possible that you can either post a picture or show us to camera what you've got, that would be great. And I'm going to see if I can switch back to my other camera. Yeah. So hopefully you can see me. It's great to see people's faces. Thank you so much. So. We're starting to get people finishing. Some of the strategies are fantastic.
I just started to use my bookshelf to create a shared screen. How about that for low-tech modification?
Oh, that's lovely. I saw a fantastic kind of drawing screen sharing thing the other day, and somebody had basically made a reverse periscope with a little mirror that you hang over your laptop camera, so it looks down at your keyboard and you can put drawings there.
George, your strategy is really interesting.
Thank you. I think I misunderstood the instructions at first, so I started off just drawing.
I really like it though. It has a really interesting regularity to it that is, there's a weirdness because once you sort of make it in, having done a couple of lines, even if you're trying to make random, you kind of get bored. You see me getting bored and just kind of wanting to put the numbers in.
Yeah.
And you just kind of go, oh, you know, let's move.
Yeah. That is so lovely. Starting to see the different strategies. George, yours is awesome. Shelvin is beautiful approach. And Lionel, now who's next to, don't have a name here, that's gone for kind of continuous dotted, separated lines to make the 100.
That's Max.
Oh, that's Max. Yeah, Max, that's beautiful. And also from Dan, a completely different approach. And Suyash, that's fantastic. And Chip, also, it's really great to see people's faces too. And the thing that I always find, I start off doing is going, oh, well, this is really clear and straightforward. Fantastic, even more drawing, is for myself noting what I'm starting to do subconsciously to improve what I'm doing, which is that actually I'm making sub-rules of every line that I draw should be at a different angle. And that after I've drawn 50, I'm starting to look for spaces to put the other drawing lines into, or I've added my own interpretations, especially how to accommodate to say, oh, the paper's this big, so I should probably start spacing them out rather than drawing them all up in one corner, or these more complex rules that I'm just doing kind of intuitively. But the rules sound pretty straightforward. And in my mind, I know what everyone's going to do. You know, like Chip and I are drawing relatively similar drawings, or maybe the angular elements are different. And then Dan has got a different strategy, which is possibly similar to George's. And these different strategies. And then Lionel has gone, well, it doesn't say the lines have to be straight. They just have to have a particular length. And that's my interpretation of the rule, which honestly, Lionel, I've not seen somebody do before, and that's genius and wonderful. But to see this diversity of drawing and to think about the interpretation of the rules behind them, for me, is really, really exciting, because out of this very simple rule set, we're getting such diversity and complexity. What I'd like to do is I'm going to go back to screen share, and
I could comment if you like.
I would be really interested to hear what people thought and what was going on.
Okay, so there's it's a really strange bridge maybe, but there's NP complete problems, and NP complete problems, like traveling salesman problem, have the property that finding a solution is really hard, but checking whether it's correct is really easy. And I think that maybe subconsciously, at least me, but maybe also George, have adopted that strategy, because while I was drawing, I was thinking it has to be checkable, very easily checkable, whether there's actually 100 lines on the paper of equal length. And while many of them are artistically more beautiful than mine, I think it's really easily checkable. So I think that the algorithms are creeping in just there in the strategy. Maybe, I don't know.
I would agree. I mean, perhaps this is part of your engineering thinking, that you're looking at what are the test conditions for this process.
Yes.
But regarding being artistically beautiful, I would say yours is as beautiful as anybody else's. And for me, the thing that I find really exciting is from simplicity comes this great complexity, and everybody's bringing different strategies to how we deal with it. And that for me also is one of the things that I love working with machines, is that painterly aspects of decorative art per se get challenged often. So I wanted to do one more exercise extending from this. So we've done this super simple thing, which is procedural, and we have an end condition, which is we've drawn 100 lines. Now we stop and we evaluate what we've got. I would like, if you can, each of you to think of a simple drawing system and write them down on the paper, and then follow the rules. Try a drawing, and then we're going to come back together and you show us the rules, but don't show us your drawing, because otherwise we'll try and imitate your drawing. And then everyone will draw your drawing. So we'll go around and we'll quickly do sort of 15, 16 drawings, if that is okay with people. So if you can, grab a piece of paper and write down some simple rules that we can share as a drawing and do together as a group. And then in UK, we say 5 minutes to write some simple rules, do a test yourself, and then we'll just go around and everyone reads out those rules and we all do the drawings together so we can compare. Is that okay with everyone? So in sort of 4 minutes, I'll say, come on, okay, we're going to do it. And then we'll just go around and each person will read out the rules. We all draw, show what we've drawn. And then I want to go on to the next piece after that, if that is okay with everyone. And while you're doing that, I'm going to sprint out, grab a cup of coffee and come back and write my own rules. So if you want to go and break and quickly get a cup of coffee and do the rules, and that's fine. And if you want to show on camera, writing together, because this is actually a really nice piece when I've done this physically with people together, that there's this air of kind of concentration and a real feeling of doing something that's shared, but also individual. So I'm gonna mute my audio, let you draw for a couple of minutes, and then we'll come back and share what we've all built together. So how is everyone doing? I have snuck out. I've grabbed myself a cup of coffee because the whole studio runs on coffee. And I'm really interested to go around the room, if that's possible, and see the rule base that people have made. Chip has got one. I think looks like Dan has been busy. Max, you're looking intent and ready. If you're okay, Chip, let's start with you. Do you want to read out the rule? Don't show us the drawings that you've made.
Okay.
Read us the rules. And
Yeah.
if everyone has a stack of paper and they're ready, let's just do your drawing, show it to camera, and then we'll go around and do Dan after, and then Max after that, if that's okay.
I just realized that the image is backwards, right? You can't read this because it's backwards.
I know, I can read that.
Oh, but is it, I guess on my screen it looks backwards.
It's backwards on your screen, but it's forwards on ours. It's a strange
really?
world.
That's really strange. Okay, so pick a number between 1 and 10. Fill the page with that many blobs. Connect the centers of each blob.
Chip, you have to connect all the centers of all the blobs, right?
Yes, exactly. Connect the centers of all, I guess.
I was going to be mean earlier and say you're not allowed to ask questions.
Okay. Okay. Well, then the rule is then connect the center of each blob.
and this is what's awesome is, as you know, I think it was Lionel completely threw me earlier with a thing that I'd not seen as an interpretation before, and how we see the interpretation of different rule systems. But yeah, we'll let that question go. Also, it's your workshop, so you have to decide the rules now. Right, when you're done with Chip's drawing, can you label it Chip's drawing and just hold it up to the camera?
Should I show you mine or do I wait to?
If everyone's done, then go for it.
Wow. That's great. So many lines.
Misinterpretation of the rule. The upper part is the proper interpretation of your rule.
It's great. It's great. I love all the lines. Here's mine.
Wow. That's really nice. Hey, I was wondering whether it's possible people could take pictures of each of the drawings and put them into the Slack channel, so that if you wanted, you could gather pictures of everyone else's version of your rule set. Because when I've done this and you lay all the drawings out on the ground, it's really lovely to see without thinking about the rule set, you can look at the drawings and go, yeah, I can see the commonality between these 10 drawings by 10 different people. And actually, what
and if you stop sharing your screen for a second, then I think we'll have be able to see the, yes, exactly. We should be able to see all the pictures together.
Yeah, my apologies.
To screen grab.
Yeah. So it's a fantastic thing to put all of the pictures side by side. And when you look at them innately, you can see there's a common rule base, and you can start from the pictures to figure out what the rules might be, which we're actually going to come to this a little bit later on, but you could look at it technically as being a hidden Markov model, which actually, you know, computer scientists amongst you may start shouting at me and going, oh, no, it's not. But it's like a hidden Markov model that you can look at all of this interpretation and start to do, oh. So yes, that's fantastic. And Lionel again has gone with a bit unexpected. Max, beautiful. Dan, awesome. This is me here being quite literal, I think. And Chips, which is your intention, is really different to what I imagined it would look like after you described the rule base. Cool. If everyone else is ready, can you either show the picture? If you're ready to go on to the next one, Dan, do you want to read out your rule base? And we'll then all share the drawing that's come from your rules. So Dan, when you're ready, read us out the rules.
Sorry, my mic was still shut. I was already doing that. Yeah, so the rule base, I also written it down so you can refer to it. I'll put it up for the camera. The rule base is consisting of 3 rules. Rule number 1, draw a line. It is one piece. Rule number 2, on every piece, cross a new line of approximately 70% length, 90-degree angle, exactly in the middle. Rule number 3 is go back to rule number 2. I hope you can read it like this. Start drawing, everybody.
Dan?
Yes?
You're in control of this drawing session, so you have to tell people when to stop. I don't know whether you want to call a timeout or...
Sure, let's do it another 90 seconds.
Yeah, because we have runaway recursion here.
Yeah, so people might be doing this forever, you're right. Okay, you cannot touch the paper more than 1,024 times, let's say like
that. Perfect, thank you.
30 seconds left. Ten seconds left. 5, 4, 3, 2, 1, and we're done. So what now, Dan? Show the results?
Yes, please. If everyone can show the results, that would be great.
Can we mosaic tile the screen?
Yeah, I think you can do that in your view.
I can do that in my
in the main.
Oh, yeah. All right, I got the same as George. Again, I have the same as George. George also did the 10 times 10 method before, right?
Yeah.
You guys are secret twins.
Is this like a fractal? This is like a fractal approach, right?
Well, Dan, you describe what you've done because you know from an engineering perspective.
Yeah. So basically, yeah, it's I was I think that the immediate gist that came to mind was how to make an interesting drawing of very basic rules. And the first thing that sprung to mind again is kind of an algorithmic thing, and a fractal, although the connected blobs was also a good idea. And yeah, it's a fractal. So and most of the people actually interpret it right in very different ways. So yeah, that's all I have to say about it.
If people are interested in the code examples in the GitHub repository, there are two things that are a little similar to this, which is looking at recursion trees, which means that you draw something and then you go back and you draw it again, but often with a slight modification to say, move to the left or scale it down by 10%. So where you see things that are self-similar, such as a fractal, or with things like, especially natural looking forms, such as tree structures, which branch and branch and branch and branch, you see this self-similarity that's a property of fractals. And there are two examples in the source code that look at how to do simple recursion trees like this, so that you can make a pattern and then repeat with a modification, repeat with a modification. But as we see here, you need to put an end condition in, otherwise the computer will spit an error at some point because it'll try and run this forever. So as Dan said, maximum 1,000 drawings or a time limit. So Max, do you want to read out your drawing to us and we'll do yours?
Sure. There's one rule, draw squares which must overlap with side lengths of I modulo 5 centimeters. That's not really, I'll write it in the chat. I is the number square, the iteration.
As a non-programmer, I need this one unpacking. I need it explained to me again, sorry.
Yeah, so modulo would be the number I
Right.
divided by 5, but just the remainder of that calculation.
Okay.
Max, can you, partner, I think there's a couple of people, and I'm also struggling, kind of going, I'm not quite certain what you mean. Where are you developing I from?
Yeah, sorry. I is the ith square, basically. So starting from, you know, your first square is I equals 0 or 1, whichever you choose. And then, you know, your second square would be, and so on.
Oh, so you count squares, 1, 2, 3, 4, 5, 6, 7, 8. Yeah.
Yes, yes.
Okay, so because you're doing the modulo, which is like 6 modulo 5 is 1 remainder. You divide by 5 and you get the 1 remainder. Like 11 modulo 5 is still 1. Okay, let's just do it and see what happens.
Right.
And Max, again, you need to tell us when or how to stop.
Stop condition would be 30 squares. This is a good lesson in how to write a good rule.
Okay, how are people doing? If you're ready, let's have a look at your drawings. So, Christina, Siyash, George, Lionel again got a drawing.
I completely didn't understand. I'm sorry.
What I love about these exercises is there's no right, there's no wrong. We're just exploring this idea of how we draw generatively, and we're using the rules to generate drawings. Jon, you've joined us. I hope that you're sort of following what's going on. Everybody's reading out drawing rules that they've made. Hopefully you'll be able to join in as we go through, but if there are questions, please ask them in the Slack channel and I'll pick up any issues and hopefully help each other out throughout.
Okay,
So,
thank you.
oh, well, welcome. Chip, wow, lots of simplicity and complexity. Max, could you show us your original drawing that you did?
Yeah, I actually wasn't able to do 30 squares, but I don't know if this is visible.
Yeah. Ah, fantastic. So you've got rotation similar to Chip, and Dan is going very Mondrian, actually very Vera Molnar, which we'll see in a minute. And George too. Excellent. Right. Suyash, do you want to read out your drawing rule and we'll do your drawing now?
Sure. My rule is very simple, hopefully. Draw 10 circular shapes. All of them should relate to each other and tell a story. So I want to focus on a story, on a concept, and just draw 10 circular shapes, and you can relate them together. That tells one big story.
Okay, could you just repeat that again as the set of rules?
Yeah. Draw 10 circular shapes. All of them should relate to each other, and in the end tell one story or convey one idea or concept. We'll stop in 30 seconds. Wow, I'm seeing some ideas. Very nice. Wow. Somebody drew like a spiral. Maybe people can tell about their projects. Okay, we're done. Let's go one by one. Let's start with Chip. Chip, what do you what was your idea? And yeah, I can show.
Sure. Here's my drawing. It's shared burden.
Ooh, nice.
It's about sharing a burden.
Nice. Very nice. Christina?
I ended up making 3 because it was such an interesting thing to do. So the first one I made was just the circles enveloping each other, and this idea of, each one eating the previous one. And it was interesting how the paper sort of broke in this point. It got so full of ink. And then I started making these other ones and trying to think of and realizing that I was making these weird spiral shapes without necessarily meaning to. It wasn't my idea. It just sort of was what the blobs wanted to do, I think.
Yeah, it's an abstract idea. Nice. And I like the depth of illusion in the middle one.
Yeah.
Dan, let's go to Dan.
Yeah. So I made 2 drawings because I couldn't really decide. So first one is very, I don't know, very basic. 10 is decomposable in 2 prime numbers in 2 and 5. So this is just 2 by 5 bar. And then I was just thinking about Chopin, and he wrote a lot of music in 3/4 measure, mazurkas and waltzes. Boom da da, boom da da, boom da da, and that's the second drawing.
Ooh, nice. Connecting music with picture. Max Cornell?
I was, I guess, thinking a little bit about center of mass and the difference between that and the average counted circle. So, center of mass probably being like here, but the average counted circle is over there.
Oh, wow, that's pretty cool. Physics. Nice. Who's ICC'20 AWS? Yeah, please.
Sorry, that's me. That's Dan. And this is the code name as the organizer. So I started out and it was about commonality, and then I realized that it was about commonality and difference, I think.
Oh, can you tell a little bit more?
Well, I love this word quaquaversial, which means outwards in all directions from a common center. And also it's my go-to winning kind of Trivial Pursuit word, because it's actually, I think it's slightly longer than bovine spongiform encephalopathy.
Wow, very, very cool.
So it's the idea of having a common center for everyone, and then realizing actually,
I see,
we don't all overlap, but we're in there somewhere. So it's people, I guess.
Nice.
Can I add a little bit to that? Because there's Serge, if you allow me, because the funny thing is that many physical systems have an 80-20 rule of 80%, like the mainstream is 80% and 20% outliers, and that's exactly what you did too, Dan.
Wow.
Dan, I love that. From an interaction design perspective, I'm always interested in the edge cases, because we can find so many people to prove the rule, but it's all those edge cases of the stuff that actually proves the systems, which I really like. So,
yes.
Suyash and Dan, awesome. Thank you.
Thank you, Dan. Let's go to the person in the red T-shirt. I don't see their name. Yep. Who's?
Is that George?
George.
George, yeah. There you go.
I was trying to draw the way comets go around the sun. I'm not sure if I did it correctly. So the central circle is the sun, and then these are the orbits of comets.
Nice, cool.
That's
elliptical. It's very elliptical.
Yeah, yes. Lina?
Oh, I'm just thinking about gravity and social hierarchy and upheaval, but it's probably too much of an idea to convey in circles, but that's what I was trying to do.
Jumping in, Lionel, I think you've drawn one of my really early favoritist algorithms, which is about the close packing of circles.
Sorry, I didn't catch that, but did you say circle packing?
Yeah, sorry, the internet connection here is going up and down, but one of the earliest algorithms that I was trying to work out, I guess I don't know, 20 years old and starting to teach myself programming, was how to do close packing of circles.
Oh, awesome.
Nice.
Right.
I started just making circle, and it came out to like a face of a clown or something like that. Yeah.
Excellent.
Yeah. Fun exercise. Thank you.
Yeah, Max, do you want to just quickly say what you've done, and then we'll move on, because I think we have 2 or 3 more drawings, and I'm conscious also of running over time.
Oh yeah, sorry, Max. Yeah, Max, go ahead. Or Max, we covered Max. Anybody?
Yeah, I think yeah, we covered me.
Oh, my apologies. Okay, so who is next? George. Do you want to tell us your drawing?
Okay. So think of an integer n between 1 and 100. Draw a line of any length anywhere on the page. Draw a line perpendicular to the last line, touching but not crossing it, of a different length, and stop when you have drawn n lines.
Right. George, do you want to just read them out again as we're doing it?
Okay, yeah. Think of an integer n between 1 and 100. Draw a line of any length anywhere on the page. Draw a line perpendicular to the last line, touching but not crossing it, of a different length, and stop when you have drawn n lines.
Okay, how are people getting on? People still drawing away? Excellent. Okay, Chip is done. I'm done. Max is done. Dan is done. Siyash is done. Christina's done. Wow. Okay, completely different strategies. Do you want to show your original drawing, George?
Oh, it looks like there are a lot of mazes. Mazes.
Interesting, different strategies that people are taking. And Dan is like mazes and then curved lines to deal with the not crossing. And I also starting to get this recursion thing happening again, where you're saying draw a line, subdivide, draw a line, subdivide, draw a line, going through a loop process. Really.
Yeah, I wanted to make it so that the lines didn't get smaller, so you didn't end up sort of stopping.
Also, I ended up exploiting a hole in your rules because it didn't say anything about your second line not intersecting.
Yeah, I saw that. I saw that. It's amazing. I saw that. It's really cool.
It's beautiful. There's some beautiful stuff coming out. Now, moving on, because I want to walk through a couple of quick code examples and wrap up in reasonable time to break and have time for everyone to talk. So who is next to read out their drawing?
I guess it's me.
Yes, please, go for it.
All right. Well, it's a quick one. Let's see if this fits. Okay, so draw 25 to 50 lines, each composed of 4 vertices. Each line must intersect 2 other lines, no more, no less.
Lionel, can you just clarify what you mean for the people that are sort of non-programmers, what you mean by vertices?
Points, like, maybe I should give an example. I mean, or maybe a straight line that changes directions twice, if
Okay,
that's clearer.
Yeah, excellent. Thank you very much.
I think my favorite is people's faces when they're trying to wrap their heads around the concept. There was a moment where we had a whole mosaic of people going,
I'll probably give a minute or so more.
Okay, if people are ready, can we see what we got?
Oh, cool. Similar yet very different.
I had a weird moment of going, I'm being really picky here, but I don't know how to start because the first line can't cross with any lines. And I'm like, no, you're being picky. Just get on with the drawing.
And I had a second experience of realizing that the best strategy, which I think is what Chip did as well, is that it turns into a chain. So
you're always connecting them together.
Yeah. So the best strategy of getting them done is to sort of chain them, which I think is what you ended up doing as well.
Yeah, I started using the corner as the first line, so I would satisfy the connect twice rule, and I just exploited that.
But that doesn't that mean that you intersected?
Oh, maybe I didn't follow the directions.
It depends.
Well, like Max did, Max broke it up into modules, so that worked.
That's true.
And I guess a lot of us just ended up in a round chain, and we were struggling to find the space to link up with the other end. Yeah, cool.
I love the approach that Max and George have taken. And Suyash is that's great. That's quite fabulous.
That's nice.
Okay. What I'm doing is of my pictures, the drawings I've been doing here, I'm taking pictures and posting them into the Slack group. If you could do that and just, if there's already a picture posted for somebody, put a thread on there so people can see all their pictures together. That would be really helpful if you could do that, because I'm trying to manage multiple things here. So I've only posted a couple, but in the break through sort of lunchtime this afternoon, I'll post more. So if you can, please do post them because it's really interesting to see them side by side. Now, have we gone round everyone's drawings or have I missed anybody out? Christina, do you have a drawing rule for us?
I do. I wasn't sure if I was allowed to play.
Of course you are. Yeah.
So I want to actually, I shouldn't explain, should I? Okay, you ready? So the rules are, I'll add them in here as soon as I read them. Put pen to paper and this is important, at speed. Don't hesitate. Draw a straight line and at your first inclination, change directions. Keep drawing straight line and change directions at your first inclination. And the second you hesitate, you have to stop. So the second you find yourself stopping already, you have to stop entirely. Does that make sense? I'll try to write it out. Let's see if I can make this.
I feel like I have to mentally prepare before.
I was about to say the same thing. Like, I feel like I have to be ready.
Done.
So put your drawing up when you're ready. This, depending on how easy it is for you to hesitate, it shouldn't take too long. Oh, wow. George, I'm loving yours. So the reason I wanted to do this was that I realized this thing of speed, like this weird thing when you don't know why you're doing something and your hand does it before you've even reasoned it. And it happens when I just noticed now that it was happening when I was following the rest of your rules, that I would second guess stuff and hesitate. And because I'm drawing with a pen, it would create an obvious blob on the paper, and I would have to hide it in order to show that I was following the rules. But my brain would sort of keep intervening in an interesting way. So my one looked like this, which is a lot like a lot of yours actually. Chip and George and Lionel, you're all in the same space as me. Max, you don't want to cross, huh?
Wow. All right, Christina, thank you very much. Thank you to everyone showing all their different drawings. I'm going to switch back to the other camera now. And the reason that I wanted to do this was actually to think about drawing and think about rules that generate complexity, because the programming aspect of it is what we're doing right now. The using C++ or open frameworks or processing or Java or Smalltalk or Python or anything else is just an implementation detail that helps us speed through complexity. But I really like doing this as an exercise because it gets us to think, before we get to the computer, what is it that we're actually trying to describe? And where does this go? And what is the relationship that I'm building here with this system that's generating complexity? So I'm going to switch to, if I can, sharing screen again. And I want to talk about generative systems. So generative systems are, from my perspective, and there's many different ways to describe them depending upon what arena you're looking at, whether you're looking at art and design or systems engineering or other things, that they produce non-explicit answers, that they're necessarily divergent, that we have usually simple rule sets, but they generate complexity, and they work out of randomness and aspects of probability, generating behavior. So we can produce change out of these things. And people produce generative systems to work in all kinds of arenas now. People are using generative systems in architecture. People are using them in chemical engineering. People are using them in product design that allows the computer to generate possibility from a rule base. Now, I want to talk briefly about some of the artists that have worked, of many, 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 that work with generative systems in some way. And one that I want to look at very briefly is Vera Molnar. And if you're interested, there's a lot of material online, not as much as there should be about Vera Molnar, possibly because she's a woman, possibly because she's working in French. But I find her work incredibly interesting. She's one of the early pioneers coming out of the 1950s, 1960s, of looking at the electronic space inside a computer to draw with. And here's a beautiful piece of video, which I have had to screen grab from the Museum of Digital Art, which tragically was completely self-funded, but has closed down now. But I'm hoping that they're going to re-emerge. So if all goes well, I should be able to play you this. No, of course not. Bear with me a moment and I will find the video and play it for you. All right, all being well, you should be able to see the video now, and I can run this.
Il y a la vieille notion romantique qui est l'intuition. Un artiste a du talent, du génie, il s'assied, il boit un vin. Il y a la vieille notion romantique qui est l'intuition. Un artiste a du talent, du du génie, il s'assied, il boit un verre d'alcool et puis il fait. Et cette intuition, on ne sait pas ce que c'est. De temps en temps, ça produit quelque chose qui vous plaît, de temps en temps, non. Alors, quand on travaille à l'ordinateur et on est moderne, on dit intuition, c'est romantique, ça ne m'intéresse pas. Mais il y a une chose qui peut remplacer l'intuition, c'est le random. Parce que, bien sûr, il y a maintenant des machines autrement plus perfectionnées que ça. Ça vous montre des milliards de possibilités auxquelles vous, avec votre pauvre intuition, vous n'auriez pas pensé. Donc, ça enrichit un peu les champs. Donc, le hasard, pour moi, ça a beaucoup d'importance, mais pas à la manière dadaïste. C'est pas pour dire que n'importe quoi peut être l'art. Au contraire, c'est pour mieux trouver ce qui me plaît. Parce que quand vous faites à l'intuition, vous faites 10 planches, 12 planches, 14 planches, à la 20e, vous êtes fatigué, vous ne faites plus rien. Avec un ordinateur, vous voyez, alors d'abord, on peut balayer tout le champ. On dit, ah, mais c'est ça qui me plaît ou qui m'intéresse, pas le reste. Donc, on met le focus là-dessus et on développe toutes les possibilités. Après, on se dit, tiens, c'est plutôt ici, là-dedans. Donc, on approche, c'est un paradoxe, mais les gens qui, au début, ont hurlé que l'emploi de l'ordinateur déshumanise l'art, c'est le contraire qui est vrai, parce que c'est grâce à toutes ces technologies qu'on arrive à approcher très près de ce qu'on a imaginé. Autrement, on l'aurait peut-être pas trouvé.
So the material that Vera Molnar was producing was coming out of very, very simple code. And my understanding is she started programming in Fortran and getting access to machinery that could run through processes and outputting through plotters, which is, if you've worked with plotters or pen plotters, is a beautiful way to work. But she produced these simple geometric rules that would generate complexity. And you can see here, these are from 1973 as a series of computer drawings with the same related rule that grows and grows and grows, changing parameters based upon the same rule set. Her work is really worth exploring, and there's quite a lot of material online, and I've been taking a bit of time to investigate and recode some of these things and port them into different programming languages, as have many other people. So if you're interested, you can find a lot of examples online where people are attempting to rediscover the rules that she'd been building for drawing. One of the other people that I want to mention at this point, alongside many other artists, from Annie Albers, the weaver, all the way through to people like Brian Eno, the musician, is Sol Lewitt, who was a printmaker who sort of became famous for writing rules for how you draw prints. And in one instance, he produced a range of rules and sent them out to all of his students to say, take an etching plate, produce these drawings, send them back to me. And then he had people print them, put them all together in a book and published it under his name, which people have varying different opinions on. But Sol Lewitt would do things like this. And this is one of the rules where he would send rules to a museum for an exhibition of his own work and have people in the museum execute the rules on the walls of the museum as a piece of his work. So like Vera Molnar, he's producing complexity from simple rules. But the interesting thing is that it's with Vera Molnar, she's not necessarily exposing the code, she's exposing the endpoint in the same way that Brian Eno would use generative systems in the music studio, but there was only one recorded version of that piece fixed at that length on a piece of vinyl or on a CD or something else. Whereas Sol Lewitt was actually proposing that the rules were part of the art, would be my comparison and argument here. So he's saying on a wall surface, use a hard pencil, place 50 points at random, and then all of the points should be connected. So you see people performing these almost as literally like a performance piece in museums now. So if I can move to Sol Lewitt drawing. This is on YouTube and the links will all be online, but you can see this, if you see the video now, this is somebody executing one of his wall drawings for an exhibition of his work. But the work has been actually executed by somebody else, but the rule base is his. And this kind of, he produced many, many different rule bases for museums, for books, for people to work at home. And you see the similarity to the things that we're doing, where the gallery assistant, the gallery employee, or the curator is executing the work of Sol Lewitt, specific to that space there.
Hey, so I have a question. So who would you say would be the artist or the creative? Would it be the person who defined the rule or the person who's doing the drawing?
That's a fantastic question. I have no idea. And this is, I think, one of the points that I wanted to get across, and Christina and I talked about this at length, about what are the important elements here. And for me, it's not the code. The code is only an implementation detail. And here, actually, this gallery employee, is unnamed person, is acting on behalf of being the computer. It's executing the rule base. And this is the interesting question for me. When you look at systems for drawing, there's these two questions. One is it the system or the outcome that's of interest to you? In sort of recording artist, it's potentially that version that got released as the LP, the CD, the song, or whatever else, or that particular print in the case of Vera Molnar. But quite explicitly with Sol Lewitt, with these activities where he's sending a list of instructions to a gallery, it's his vision for making a space that can be interpreted that is explicitly generative at the point of consumption. And my argument is that it can be many of these different things, and it's for the individual artist, designer, engineer, creator to make this distinction and this decision. But I think it's really important that you think about it, because the generative aspect of working with complex systems can exist in a number of different places. I can build a drum machine that has random and generative elements built into it. So I'm sort of collaborating with the system inside a drum machine when I'm recording a track. But if I record it and issue just that one, the generative system becomes part of my process, making linear fixed items. Or it could be that I program the drum machine and give that to people. And actually the algorithm performs in real time for people. So it's this interesting tension between where the generative aspects occur. Is it the system or the outcome that's of interest? And for some artists, it's very, very explicitly this possibility space. So they're designing a set of possibilities or instructions rather than the finished item. And so, yeah, in answer to your question, I don't know where the art lies, but that's what I find intriguing and exciting.
I think just to jump in here, I think for me, it's in that, because I'm working with large, semi-intelligent computer-driven systems like industrial weaving looms. What we're seeing is a sort of a ridiculous combination of quote-unquote stupid machines and smart machines and semi-stupid machines. And I think for me, the interest lies in the collaboration between the human and the machine, the wanting to stop, start, get bored. But, you know, you want the machine to do, when we were doing the drawing exercises, the hardest thing was to was to keep count. At some point, I stupidly chose 59 as my integer, and it's really boring to keep track until 59, but this is exactly what the computer's really good at, and I'm really terrible at, because I get excited about the drawing and then I forget where I am. And this idea of so for me, I think this idea of collaborating with machines is where the sort of interest lies. Sorry, butting right back out again. Dan, it's
no, thank you. I mean, that is exactly the question, that we see artists, designers, engineers working with complex systems. and increasingly people talking about working with algorithmic work and machines that have some behavior, complex behavior inside them, and having outputs, and asking this question of whether the collaboration is important or only incidental to the end product, and what the status of that end product is, either as a physicality or as a potential. I want to go to a code example now and actually switch a little bit and talk about randomness in the drunkard walk. And a random walker, sometimes called a drunkard's walk, starts with an initial point and then moves in a random direction to a new point at a specified distance. And from there, it moves to a new random point and then does it again. So we have recursion, as we've seen. And you can add additional rules. But it is this staggering from one point and then staggering to the next and staggering to the next and staggering to the next. And I'm going to show you a code example, and I'm going to introduce an idea a little bit faster than I wanted to, but I'm conscious of time. And the random walk that we're going to look at can go up or down or left or right equally randomly. And then when it comes to the next loop, it can go up or down, left or right equally randomly. And we have an ending point. In this case, I can hit the escape key and it'll stop. I could say after 1,000 or after 10 minutes or some end point. So it has 4 chances of what it will do next, up, down, left or right. And you could look at all the possibilities of saying I went up and then I went left and then I went down and then I went right as a chain of things that it has done. And this in computer science is called a Markov chain. And the idea being that there's equal probability for going up, down, left or right, depending upon what you did last. But I could say, if you've already gone up, make it less probable that you'll go up again. Make it more likely that you'll go down or left or right. And then if you've gone left, make it less probable that you'll go left. So instead of just introducing randomness, we introduce randomness and a range of probability, and we start getting more and more complex systems that we can get to do things that are more like what we want. And one of the things that happened out of the drawing is that everybody had an idea of what kind of drawing they wanted. They wrote rules, but as each of us was implementing it, we were tuning based upon circumstance. So I would draw a long line to one side of the paper to get to near the edge of the paper because mentally I wanted to fill it, and I would draw down and I would start accommodating based upon what I'd already done, shifting the probability. And this is what we do. So our rule can move up, down, left or right, and the simple code is in the examples at random walker if you want to have a look through the code, but I'm going to flip to it now and walk through it very, very simply. So I'm using Xcode, but you could be, hopefully you can all see my screen.
Can you make the text a little bit bigger?
Yeah, of course. How is that?
Good.
Okay, so in openFrameworks, like pretty much all C programming, you have an area that defines what your functions will be and what they might do. And in this instance, it's in my OF app head file. So the header file has a main loop and a couple of things that the main loop will do. I have a loop that will set things up, a loop that will run continuously to update what's going on, and then the loop that says draw. And then I'm catching 2 functions to say, has something been pressed, a key been pressed? And in my main file, I have my setup loop here, and it just switches on blending. In openFrameworks, any command that begins with OF is something that's built into the openFrameworks library. And what's really nice is there's lots and lots of simple stuff that's built in already. If I want to play a sound, I just call the OF sound player. It makes it super quick. If I want to draw an image to the screen, I can make an object called OF image and draw into it. If I want to load a picture, I can do the same. And there's lots and lots of additional libraries that are very easy to link to. If I want to talk to a Kinect camera, I want to take an input from a MIDI synthesizer, I want to control a laser, I want to go and grab images from the web. So it's an extension that sits in C++, but what's really nice with openFrameworks is if you download the examples, there's loads of stuff that works straight out of the box. And when you make a new project, you get sort of an empty document with lots of routines in. So we only need to put in the things that are special for us. What I've made is in my update loop, I have, I'm going to talk a little bit of programming. I've made a class called a walker. So this is a little code object. I look at my header file, that when I make a walker, it's a dot, and it can have a number of points inside it. Then it has a list of those points. So like a long array, here's an XY point, and here's another XY point, and here's another XY point, and here's another XY point. And I'm calling that the walk. And the walker can have a color and a radius of the dots that it's going to make. So the first thing that I do is I say, I want to make this simple walker. So it basically is a list of points, and I make the points and put them into the walker, and the walker list gets longer and longer and longer and longer. So in a loop, I'm in this OF update loop, I'm saying, go and update the walker object that I've made. And in the draw loop, I'm saying, go and tell the walker object to draw itself. When I make the walker at first, this looks a little complicated, but I make a point and I say, get the width of the screen and divide it by 2, get the height of the screen and divide it by 2, and make that our start point. So the first point is just the middle of the screen, irrespective of how big the screen is going to be, which is like me mentally calculating where I'm going to start on my paper to fill it in. And then I use this command pushback, which just says, takes the first point and push it into the walker. So that becomes the first in our list. And then I set the color to be a particular color that I want. And in this case, it's RGB. So it's 0 to 255, the maximum colors. So it's 255 red, 255 green, 255 blue. And then I can also, with openFrameworks, when I make a color, I can optionally add a blend value at the end. In this instance, I'm adding the blend value 10. So if you want to go and mess around with a color, it's here. And then the dot size, I'm saying to be 2. And when I tell the walker to update itself, which is go and make a new point, please, I set the step size. This is how far it's going to walk each time. And then how many choices it has. So it has a choice of 4. So I say, roll a random number using OF random between 1 and 4. And then I'm using this switch statement. So it says, grab whatever has been put in random, 1, 2, 3, or 4. And if it's 1, find out where we were and move upwards. If it's 2, find out where we were and move downwards. If it's 2, 3, 4, go up or left or down or right by taking the last point and moving from there by the amount of the step. It makes me a new XY position, and I just push that onto this list. And in the next, in the draw loop, it comes and does this simple function. It sets my drawing pen to be whatever the color of the walker is, and loops through with this loop. How many points are there in the walker array? So I say, how long is the walk? Walk dot size. How many points are in there? And go and draw a dot of whatever size I've said at that point. So it's super simple. And when I run the code, it will go through this. So I have 4 possibilities of equal probability, up, down, left, or right. And I'm just generating more and more points in my list and drawing them to screen continually. And if you can see on the screen, it's slowly building up this cloud. And what I said was, because the walker will keep going back over itself, make the dots semi-transparent. So the more it walks over itself, the paler and paler that point will become. So actually what I could do is I'm starting to build up this noise cloud of where the walker has moved around. If I go back and in my walker, change this last value, which is the transparency, to be a little bit less transparent, and run it again so this will compile the code and make the application for me. You can see it filling in. Now I've chosen to make the walk step the same size as the dot, so we get this really nice mosaic feel. But what I could say is actually make them much bigger or smaller, or instead of drawing a dot, draw a line from one place to another. Or I could say, if I wanted to get into what's called higher stochastic functions, I could say randomly walk between 1 pixel and 5 pixels from the last space, and then randomly choose the dot size rather than it being the same dot size each time. But I have this simple rule with probability based inside it that allows me to start to draw. And this randomness, and a walker is a classic example of randomness, is the beginning underneath lots and lots of pattern making. And as we did with all of our drawings, as I have Lionel's drawing, George's drawing, Suyash's drawing, and so on, I'm starting to put filters on them. And I can look at this and say, well, actually every X dot, random number between 1 and 10, is going to be red, is going to be blue, or randomize the amount of transparency by putting random numbers in. But what we start having is chains of really complicated interlinked randomness that go into this bizarre place that drives mathematicians wild, either with craziness or orgiastic frenzy, I'm not sure which, but starting to read some of the mathematics and exploring walkers for a long time as a way of saying, actually, output these as notes. So we have velocity vertically and pitch horizontally. And hey presto, we have random fractal jazz, which usually sounds awful, but we start filtering it to say, if this is happening, cut out those notes that are really jarring and make it sound much more like I want. And I start tuning the system in the way that Vera Molnar was talking about, saying the computer doesn't do it for me, but it allows me to explore thousands of possibilities and investigate spaces very, very quickly. So that's one of the things that I find really exciting. Now, in a minute, we're going to finish this portion of the session. And what I'd like to do is offer up some of the example code that I've put online that you can go and run these right now. And the very simplest, go and have a look at the walker and just, if you're not used to programming, punch in different numbers in different places and see what happens. But I want to show you something a little bit more complicated, because in the walker, we roll a random number and we have these 4 possibilities of what it will do, to go up, down, left, or right, and they're equally probable. But like I said, I could say, if you've already gone up, the next thing in the chain, because this list of points that it's walking through as a chain, is different. And we get to Markov chains to say, if you're at condition A, what are the chances of going to condition B? And if you're at condition A, and it's equal that you could go back to A or go to B, we have equal probability. But it might be that if you're at A, it's 70% likely you'll go to B, and only 30% likely you'll stay at A. And we start making this interlinked randomness in a chain. Now, the example at setosa.io is beautiful, far better than I can describe, but I really do recommend you go and have a look, that you can see, if you can see the example on screen, of a 2-state Markov chain. But we can expand that to say there's multiple states, and we can change the weighting, that if you're at A, you might go to B. If you're at B, you might go to A, and so on. And we can go on to more and more chains. And this is the root underneath lots and lots of drawing and lots of music and lots of other examples. From a code point of view, I want to show you this simple thing. And what I did was I found myself doodling a lot. And I would do different kinds of shapes in the way that you know, I've done this sort of drawing, and particularly with Christina's instructions, where she gave a mood and a speed, a temporality, and I'm getting drawing like this, and I recognize my own doodles. And I started looking at the doodles saying, well, what do I do? And can I describe in a set of rules what happens next? So I tried to, and I built a Markov chain for my own drawing. And I realized that I was doing lines and arcs and squiggles and dots and circles and squares. And I started looking through the drawings saying, well, you know, if I've gone up, how often do I keep going up? How often do I do these different things? And I put into a spreadsheet what happens if I make a line up, down, left, or right, and draw an arc up, down, left, or right, and then a circle, a square, a loop, or a squiggle. To make a Markov chain like this, each line going across must add up to 1. So if there were 10 options that you could do next, and each one was equivalent, they'd each be 0.1 possibility. So if you were thinking about doing this with dice, which you can perfectly well, there were 10 possibilities, they're all equal, I get a 10-sided dice and just roll it. If it were that option 1 was going to happen 50% of the time, that would be 0.5, and the next 9 would be whatever 0.5 is divided by 9. So each line adds up to 1. So I wrote a simple program that does that. And instead of it doing the drawing for me, it tells me to do the drawing. And I'm going to run it now, and hopefully we can all do one of my drawings based upon the system is telling me to draw. And I kind of like this idea in that instead of me telling the computer what to do, I got to a position where the computer's telling me what to do, and then I execute my own drawings. So I've turned myself into a plotter. So if you'll bear with me, can we do one of my drawings? Right, I'm going to compile this now. If you can still see the screen, this should compile.
Take a piece of paper and a pen and draw.
Okay, so I put a simple GUI in here so I can speed up the commands, and it will just tell us what to do.
Take a piece of paper and a pen and draw. An arc right.
So draw an arc to the right.
Line up. A circle. And a line left. Then a line down. An arc left. An arc right. A line down. And a line up. Then a squiggle. Next, draw an arc left. And a line down. And stop there.
So I built a simple system that's based upon an extension of using the random walker with this extended set of possibilities of not just up, down, left, or right, or forwards or backwards. And then when, hey, I can scan these little icons in, and it just goes through and says, show this icon on the screen. And I'm working on a Mac here, but it makes it really simple to access the system speech. So I just say this thing. So let's have a look at what everybody got.
Can I just say this is super helpful. The drawings are helpful for somebody who's left-right confused like me. So I had to look up every time and confirm the left and the right because, you know, this is how we are. But mine closed. I had the starting point and the ending point meet, and I wasn't trying to do that.
Wow, that's really, really interesting. It's really nice to see because it's always different.
Like I took it when you said next to start like a new drawing.
It's open to interpretation completely. Yeah. It's open to interpretation.
But we all have one circle, more or less.
Yeah, and a squiggle. Yeah. So we've been going for about 2 hours. And for some people, it's lunchtime. For some people, it's breakfast. In some people, it's way past bedtime. And I wanted to sort of wrap up and pause about here. I can go through the code and I can take it apart. But essentially, what it's doing is an extension of this really simple random walker, bringing in probability and thinking about this interlinked sets of probability, and then tuning it based upon my preferences of the kind of drawing that I would like. With this particular Markov chain, you could put in additional commands to say, roll a random number between 0 and 1, and if it's 0, say, draw slowly. If it's 1, say, draw fast. And this particular piece I really liked because I was struck by the change in relationship that often people look at generative systems and the computer will execute everything. But interestingly, when we look at the example of Sol Lewitt, he's getting the gallery people to execute, as opposed to Vera Molnar, who's getting the computer to execute and saying, this is the printout. And I've tried to buy some Vera Molnar printouts, particularly somebody that I care about very much. Was her birthday recently and was negotiating with a gallery in New York. She doesn't know this, but negotiating with a gallery in New York to buy one of Vera Molnar's prints. And oh my gosh, they are expensive. But they're printed on garbage computer printer paper with the little tractor holes down the side of it. And for me, the exciting thing is the rules. But we get into this interesting discussion, which in design, in art, in creativity is where the creativity sits, where the value is, and value of scarcity, and a whole range of things to which, honestly, I don't know what the answers are. And I think they're different for everyone. But this is what excites me about drawing and working with computers, is this negotiation with the system and wondering about whether it's an extension of me or a collaboration with an external system. So I want to pause in a moment. I want to quickly go around and do questions. I'm going to be on Slack, and I would like to ask you if you would like to investigate some of the example code and produce your own system. Now, if you want to work in a different environment, even if it's just to say, hey, I've been refining these rules and I've written them all down in the style of Sol Lewitt, then do that. If you want to work in Python, work in Python. I don't know Python that well. I know openFrameworks and a couple of others more. And if you want to work in openFrameworks and start to explore, have a look at the random walker. You can download it. It fires up immediately. It'll run. And you can start poking around in how the draw loop works and so on. Start playing with colors, etc. And please use the Slack channel to post questions. And we will be meeting again at, Christine, is it 4 p.m. Lisbon time, I believe?
I think so, yes. That's 5 p.m. Central European time.
Yeah, yeah.
And also just to broaden it, if you are not a programmer, I personally will be working in Thread today. So there's lots of opportunities if you're finding that the programming examples are too far away from your area of expertise, you can always find your nearest parallel.
Yeah. Yeah, so I think what I'd like to do is just run around and see what people would like to do at this point and how best Christina and I can support you in you investigating, whether you're interested in looking at code, you want to find more about openFrameworks, you want to have a discussion about where the artistry lies, or do some more collaborative drawing. Can we just go around the room and see what people would like to do? Chip, do you want to start off? I see you're unmuted.
I think
you get picked on first.
That's fine. I think what I'm going to try to do, or what I'm interested in doing, is I've been writing a generative drawer in Python, and when I try to play around with openFrameworks, I'm particularly interested in trying to learn the drawing, kind of like how you learned your own Markov chain of how you draw from someone else who's drawing. So maybe I can try to do something where you're drawing in openFrameworks and is trying to learn some Markov state, like you're going to the left, you're going to the right, that kind of thing, and see if I can make a walker that's very similar to that.
Nice. That's a really, well, you've got two parts. One is the analysis tool to build your probability chain, and the other is the output. Nice project.
Yeah. You're mute. You're mute.
And you're muted.
Sorry.
You're mute.
I know. Story of my life. Max, to ask you, if you're going to be able to join us this afternoon, is there anything that you would like to have a look at you're interested in investigating?
A couple of things. I will join this afternoon. I am going to try to get, I don't have a C++ coding environment set up on my computer, so I'm going to try to do that and work on the random walker that you were showing us, and maybe try like using some different default parts of the open frameworks toolkit in your code. And then thinking about trying to do something with audio as well with that. I don't really know what I'll do right now, but start there and hopefully end up in some kind of audio realm.
Okay. I'll put a couple of links in if you're particularly interested in audio. Random walkers, Markov Chains. There's a beautiful series of blog posts that I saw of somebody taking apart some of the Markov Chain random work from Brian Eno and recoding it in JavaScript. And I've made versions of it in openFrameworks, and also put some nice audio samples that are a good start point that will run straight out of the box. So I'll put some links in. And on my YouTube channel, there's an intro of downloading openFrameworks, installing it, running the first examples that you can follow. But at openFrameworks.cc, there's really good documentation about downloading for your operating system. And what's nice is you download it, and there's a whole example folder full of audio, video, graphics, input, output, all kinds of examples to work through that might fire ideas or give you a start point to go and hack somebody else's code.
Great, thanks.
So Yash, what do you think you might do? Will you be able to join us later?
Yeah, I'll be able to join for 1 hour, the first hour later. I personally like to play around with cards, and I like the dice idea. You know, it creates random values. Playing cards also have a lot of randomness. You know, when you shuffle them, when you take out a card, and so I don't know what it may be, but maybe implementing some of these algorithm like shuffling or something in openFramework for playing card, and then using that to derive something. It could be audio or visual.
Well, that sounds great. Will you try and work in openFrameworks?
Yeah.
Okay, great. If you want to work with openFrameworks, the simplest thing is to use the OF sound player. And you can take a sample, whether it's like an individual piano note or a dog or a jet plane or whatever else, or a piece of your own speech, and very simply load it into memory. And the command to make it play is just whatever the name of your sound is, .play. Super simple. And then if you want, you can also control the panning, the playback speed, and the volume. But it's very, very quick to get going. If you haven't looked at openFrameworks, again, download, have a look in the examples folder, and there's sound player examples that you can hack straight away.
Nice. I also had a few questions when you were talking. Maybe you can ask them later.
Yeah, please do post things in the Slack channel. And also on the Slack channel, we can talk on video. So if need be, we can do screen sharing, because at this point, we'd be getting sandwiches and pizza and coffee and sort of going around everybody's table and seeing what they're doing. But given that some of you are thousands of miles away from me, that's a little complicated right now. So Christina, what are you going to be working on?
Like I said before, I'll be having a go at making a completely low-tech version, simply because I am already quite sort of squarely involved in figuring out some embroidery samples. And one of the things that we've been looking at is people creating code to generate embroidery patterns for digital embroidery machines. We tend to, in my lab, we tend to use embroidery machines as a way of creating enforcement shapes for things that may be inflatable and all sorts of things. So I'll be looking at that, but I might simply see where my sort of inspiration takes me, and I might simply actually just have a go at doing some hand embroidery for the day. You're still muted. Dan, you're muted.
Complexity. Christina and I will be following this throughout the week and hopefully supporting and see if there's more interest and more discussion. So please do let us know in the Slack channel, or you can email us. Also, our contact details are on the workshop web pages. So George, if you're still with us.
Hello.
Hi. Will you be able to join us this afternoon later on? And are there particular things you're interested in having a look at?
I'm going to try and work out how to use openFrameworks, probably starting off with your code. I'm not really sure what I'll do though.
Okay, great. As I said, questions in the Slack channel, really happy to help out. openFrameworks documentation is very good. And if you download, it comes with lots of examples. So basically you just go, does the example compile? Awesome. Now I know my whole environment is working. C++ is a little picky, but openFrameworks is a great place to start if you have some basic understanding of being able to make loops and what a variable is.
Okay.
Right. Lionel.
Yes.
Will you be able to join us later?
Well, my time zone is currently late in the night, but I'm gonna try. As for openFrameworks, I'm gonna get it installed and running on my computer, but I'm also debating if I should stick to P5 and processing just to make it easy and faster for the learning process and not be, stumbling over the unfamiliar code. So I'll probably try to do that. But for the subsequent sessions, I'm quite interested in other explorations of formulas, like the Markov chains, for example. Maybe other things we can look at in terms of generating randomness in lieu of creativity, things like that. Yeah, I would like to see more of those.
Cool. I think your point about sticking with P5 is potentially a very good one. When Christina and I had talked about this initially, we thought we would have one complete day or possibly even 2 days where when it's hands-on and we can sit side by side and make sure that everything works, we were going to turn up with a whole load of Mac minis with everything pre-installed, and people could just sit down and know that it works, and you can start tinkering with code that already works. But given that we have this distance, go for whatever's going to be quickest to get you exploring ideas would be my suggestion. Dan.
Definitely, thank you.
Cool. Dan, are you still with us? Dan may be with us, maybe not. So I think that's Yingtao Qian. I see you're with us, possibly.
Yes, I think I'm.
Hi. Will you be able to join us in the next session or follow on what's going on, sort of time shifted through the Slack channel?
Probably not for the next session. It's going to be late. My time zone. Yeah, I think that just like P5 and the openFrameworks looks pretty interesting. I just went through a little bit like its document. It's definitely well written, clearly designed. Actually, I wonder if there's like any like a model zoo or like just a library or just like a gallery of places where, for example, the artist using the openFramework can upload and sharing their artifacts. It's just like for the open processing, there's, well, definitely open processing, the website, and there has been such kind of places where people can post their works. I wonder if there's any like equivalent for the openFramework.
They're not exactly, but there is, if you go to openFrameworks.cc, the website, there is a forum that you can click on, which has got a very lively help community, all the way from absolute beginners to some of the people that are involved in building and writing the openFrameworks environment. And there's also a section there to show off where people are going, hey, here's my first project. I've never programmed anything before. Or here's some huge installation that I've built for the last 3 months. So it's a really nice, friendly community. And you can show work there and see work there. And also, if you do a quick search on something like YouTube using the keyword openFrameworks, or on Vimeo, lots of people are posting either tutorials, short tests, examples, and quite a few people will go, hey, here's this thing I've been mucking around with, and you can find the source code here. So there is quite an active community, and just use the openFrameworks word, all one word, as a hashtag. But you can start the openFrameworks community, or if it would be helpful, I'll post some links into the Slack channel.
Ah, I gotcha. Yeah, thanks.
Okay. So yes, did I ask you? I'm trying to remember. My brain has been a little fried talking so far.
Yeah.
Cool. Okay. Well, does anybody have any additional questions at this point? No. Okay. Chip, you're muted.
So we'll meet back here at Zoom at 4.
Yes. Yeah.
Conference time.
Yeah. So the next Zoom session is scheduled. You should be able to get the link from the conference Google Doc and also from the Slack channel. So I will see you back here at 4 p.m. Lisbon time. I'll keep an eye on the Slack channel between now and then, answering questions and picking things up. And I just want to say thank you all so much, coming from all the different time zones. It's really difficult doing this. And I just want to say thank you for supporting the conference and supporting the workshop. I want to say thank you to my co-chair, my co-workshop organizer, Christina. And hopefully I will see you all this afternoon. Please do follow Christina at Canned on Twitter. And you can also find her at Technical University Eindhoven and find out more about her writing and her papers and her work. You can follow me at Dan Buzzo on Twitter, the YouTube channel, questions in Slack. And I just thank you very much for your time, your contribution, and your excitement and energy.
Thank you.
We will see you in a couple of hours' time.